Today we want to present you our final Java course project and explore the classic game of Sokoban. Let's dive into the main components of our game, the client side, based on MVC design pattern containing all the logic of the game and the game representation implemented with the JavaFX graphic library. The main server will handle multiple clients and their requests. The server is managing the high scores data, contains an administrator graphical interface built with MVVM and uses TCP and HTTP protocols for communication. In addition, the server contains level solver component that solves a given level using best first search and strips algorithms. The third component is the web service, implemented as a REST API. The service communicates with the database using Hibernate ORM library and Microsoft SQL, serving as a cache server for the solutions of the levels that are already solved. The REST architecture is implemented using the Jersey library.
Now, let us demonstrate the communication process of a player wanting to solve a level. First, a client will ask for a solution from the main server. The server will start a new thread, compress the level using Hoffman compression algorithm, and make an HTTP request asking whether there is an existing solution. The REST API will then query the database whether there is an existing solution and return the answer to the server. Let's assume there is no previous solution. The server then will ask the solver component to solve the level and send a new solution to the web service so it can be stored for the next time. The final step is the server sending the solution to the requesting client.
Now, we will present the client side. It is implemented using MVC architecture. The view is responsible for presenting the level and other data to the user and runs on its own thread. The model is responsible for the game logic and the data and the services. The controller component will manage all the communication using a general controller. The general controller holds a blocking queue of commands using a command pattern. Some of the commands, such as IO, will run on their own thread. The whole communication between the components is decoupled using an observer pattern. Here, in the code, you can see how we initialize the game and the way the MVC pattern allowed us to achieve full decoupling between each component.
The main server. The server has the administrator interface allowing to control, open session and tasks, implemented with MVVM architecture. The code demonstrates how the view is bind to the data in the view model, one-way direction. The view model will hold all the necessary data to be shown and interact with the controller, thus allowing us to decouple the representation logic from the representation view. Let's play a little bit. Now, first we'll run the REST server, and then we'll run the main server and enter the admin username and the code and start server on the default port. Now we'll run two clients, one mail, and we'll load a level, and the other one will be not sure, and mute for you. Load another level. Let's start with the easy one. This is an easy level, so I can solve it. Daniel, and you can now see the high score Daniel has been saved, and also I can look for different levels like level 1. And now let's try the other one. This is more difficult, so I might use a hint. So I'll wait for a second to the hint and move right, but I'm not sure, so I'm moving left. Now I'll use the solver to solve my level. Whee! Yeah! And the solver does it all.
Now, we would like to go in depth and share a challenge we had to face. Can a player move in a certain direction? What if we wanted to change our policy today? What if we wanted to allow 6 boxes to be moved, add 2 players at once, or even adding a new item? Our solution to that problem was what we call the path vector. First, in our funnel, the user asks whether he can move left. Next, the path extractor component will receive the level and extract the requested path to the destination. Then, it will pass it to the game policy. The game policy will then extract the path vector and explore it with questions like, can all the items be moved? How many items can be moved? Is the target position steppable? And even whether the player has a power bonus. The policy will return a Boolean answer of true and false, indicating whether the player and the move can be done. The design helped us to achieve the decouple between the game policy and the game logic, add new items on demand, and change the policy with a low overhead. The project is well commented using the JavaDoc official format and has a JavaDoc for each component. Throughout the project, we used Git to manage our code and GitHub as a remote repository. In summary, here is what we learned. There are big ships and there are small ships, but the best ship is friendship.
Yay!
Feel free to contact us.